Alright, guys. So yeah, the part is, so the last video we did how to multiply matrices. So in this video, we learn how to, which is the first part of the inverse. We're building up to the inverse of our matrix. So the first part you need to know is how to find the determinant of our matrix, right? So and this method is specifically for 2 by 2 matrices because the others will need a different method. So be careful, it's only for 2 by 2 matrices. Have 4 elements, A, B, C, and D. Okay, so simple, just one equation. The determinant of a matrix is just equal to A by D subtract BC. So if we have a 2 by 2 matrix here, so just the two diagonals, you have this diagonal here and this diagonal here. So it have one diagonal and the second one. So it's basically the first diagonal subtract the second diagonal, if you want to look at it like that. Okay, so just AD minus BC, one simple equation, AD minus BC. So let's try some questions. So if inside here we had 3, 2, 4, and 6. So the first step that I like to do is to label it, meaning like write the A, B, and C. So this will be A, B, C, and D. So the determinant of this will equal to A by D, which is 3 by 6, which is 18, minus B by C, which is 2 by 4, which is 8. So the determinant will be 10. Alright, very simple. Very simple. So let's try one more. So if we have, say, 10, 6, 3, and 2. So same concept. First thing you could do until you get accustomed to it. So there's A, B, C, and D. So you'll know what A, B, C, and D is. So the determinant is equal to AD minus BC. So it's the first diagonal AD, 20, minus B by C, which in this case would be 6 by 3, which is 18. So the determinant will equal to 2. Okay, and that is very simple how to find the determinant of a matrix, AD minus BC. Alright, so some theory. So there are two types of determinant. The first type is when the determinant is equal to 0. Okay, so determinant, when the determinant is equal to 0, you call it a singular matrix. Okay, so for example, if I have a matrix C 2, 2, 2, 2, and I want to find the determinant of that, so same steps A, B, C, and D. So in this case, the determinant A by D, which is 4, minus B by C, which is 4, so is equal to 0. So since the result is equal to 0, this will be a singular matrix. Okay, so when the determinant gives you a 0, it is singular. Alright, and the last type is a non-singular. So there's when a matrix determinant is not equal to 0. So those are the ones we've been doing before. Okay, so if you have 3, 1, 4, 6, and you want to get the determinants of this, so label it A, B, C, and D. Determinant would just equal to AD, so it'll be 6, 3, 6, 6 by 3, 3 by 6, 18. Subtract B by C, which is 1 by 4, and you'll get 14. So since this determinant is not equal to 0, it'll be non-singular. Okay, so from the end of determinant of a matrix. Remember, the determinant is just AD minus BC, is only for 2 by 2 matrices. And if the determinant is equal to 0, it's singular. And if it's not equal to 0, well, it's non-singular. Alright guys, so that's all. Later.